Hello everyone, welcome to part 4 of the Mercury SR2. In this video we're going to be looking at installing multiple servos per flight surface. So one of the big things on forums and that I see mentioned is people get confused as to how many servos can be supported per flight surface with respective to the PowerBox units like the Mercury, the Royal SR2, also the competition SR2, and a lot of people get it wrong. So for instance, the Mercury SR2 features 3 gyro outputs, and a lot of people mistakenly think they're limited to basically 3 servos per flight surface. So if they got a sort of a large aerobatic plane, they might have 3 servos in each aileron, and they think, okay, Mercury's got 3 gyro outputs, so therefore I can use a maximum of 3 servos on my ailerons. Well, that's totally incorrect. You throw that out the window, because I'll show you in this video how you can actually set up, say, 5 or 6 servos per fly surface. It's not related to the number of gyro outputs. So the gyro outputs really pertain to how many functions we can control independently with each of the gyro outputs. So if you've got 3 gyro outputs, we could assign one, say on rudder, for instance, probably a good example. We can have one just for the rudder function, and we might have 4 servos on the rudder, but you're only using one gyro output to control those 4 servos. And then you might use one of the other gyro outputs to control, say, your nose wheel. If you want gyro control on your nose wheel, that would use one of the other gyro outputs for a total of 2, which would still leave you one up your sleeve for a spare for whatever else you want to use it for the rudder function. So the main thing to keep in mind is the gyro output has no real bearing on how many servos we can fit to our flight surface. The only thing that really limits how many servos you can fit to your flight surface is really the number of ports available on the PowerBox unit. So for instance, the Mercury features 16 servo ports. The competition SR2 features 22 off the top of my head. And then you've got the Royal SR2, which features the full complement of 26. So really the only limitation is the number of ports on the unit, not how many gyro outputs are featured natively with the unit. And you'll see later on how we can set up more than say 3, 4, 5 servos on the Mercury SR2. So I'm using a Mercury SR2 for this particular example, and I'll show you it in a few minutes because it's just basically hidden under my display at the moment just to tidy up some of the wiring. Now, part of using multiple servos, one of the other features we need is servo matching. So when you have multiple servos on each wing, you don't do the servo matching through the transmitter. You do it through the PowerBox unit. So the PowerBox units like the Mercury SR2, Competition SR2 and the Royal SR2, they allow us to servo match on all the channels. So we can basically match all the servos, or basically control their throws and whatever from within the PowerBox unit. So we're not limited to what the transmitter can do in that particular scenario. And you'll see why you need to do it through the PowerBox unit rather than through the transmitter. One other thing I'll cover in this video, some people have asked me to cover. I was going to do it as a separate video, but I'll incorporate it in this one because it's just handy for this particular video, is channel reassignment, or changing the output mapping to basically change the ports that we want to plug in the servos. So I sort of covered off that a little bit in, I think it was part one video for the Mercury, but I'll go into a little bit more detail in this video, and I'll show you how to reassign some of the servo ports, move the function over to another port. And we'll do this with this particular example, because remember, this example here is from a previous video. We've got a separate left and right aileron, and we had 2 separate elevator servos for a split elevator function. So basically one elevator but with 2 flying surfaces, or like a left and a right, similar to aileron setup, I suppose, and then just a single rudder servo. So for this video we're going to convert this aircraft to a 3 servos per aileron type of wing. So I've actually knocked up a little model here. I was going to do a 4 servo, but 3 servos will show you how to basically do it, and the converting to 4 servos is not a problem, or even 5 or 6 servos per aileron. So this little test bed here, this is going to be our aileron wing. So we've got a left and right, and we're going to have 3 servos per side. Okay, just before we move on, I'll zoom into the course screen again, just to re-familiarize everybody with this particular setup as far as the functions are concerned. So let's do that right now. So one thing to be aware of when you're using the setup assistant with multiple servos, if we go into the setup assistant screen, when it comes down to selecting the servos, we hit next, you'll notice here we've got ailerons 2x1, so that's 2 function, single servo. Let's see what options we have. If I select that and then scroll through the options, we have a 2x2, so you can have 2 servos, a 2x1, so 2 functions, 1 servo. However, they're the only 2 options, so there is no 3 or 4 or 5 servo option. So there is a limitation when it comes to the setup assistant as far as the number of servos is concerned. So if you go to elevator, the maximum, let's go back into the elevator again. Again, the maximum number of servos we can select is 2. So 2 functions, or 1 function by 1, 1 function by 2 servos, 2 functions by 1 servo, and then the maximum of 2 by 2. Same goes for rudder. If we go into the rudder, our only options are 1 by 1 function, so 1 function, 1 servo, 1 function, 2 servos, or 2 functions, 1 servo, and a 2 by 2 option again. So you can see from a setup assistant perspective, you can't select, say, a 3 servo flight surface, or a 4 servo or 5 servo in that, for that matter. And that's just a limitation of the setup assistant. So what I would normally do is just use a basic configuration. Say, for instance, in this case, we'll be using a 1x1 for the rudder. The existing elevator, I think we had originally set it up as a 2 function because we've got the left and right functions on the radio, but just single servo. And same goes for the ailerons. And then we can just add the servos manually. And again, watching this video, you'll work out how to do that as well. I'll step you through that process. So just keep that in mind. There is a limitation insofar as a setup assistant is concerned. It doesn't cover all configurations. If they tried to do that, it'd be pretty crazy sort of programming, because there's lots of different options, and yeah, it's just sort of a bit of a waste of time when you can easily add them manually anyway. As long as you understand using the setup assistant to get the basic configuration occurring, and then we can just add servos to it. And that's what we're going to be doing in this video. So we're going to use the configuration we used in video number 3, where we set up the gyro. We're covering the gyro aspects. And we're just going to modify that configuration and add 2 extra servos per aileron surface. Okay, so hopefully everybody can see the or read the screen a little bit better now that I've zoomed up into it. Let's have a look at our functions just to refresh everybody's memory. So we've got a throttle function. We're not really worried about it in this video. The main ones we're going to be interested in is really the aileron function, because I'm just going to concentrate on ailerons, adding multiple servos to the ailerons, and the same procedure can be used for the elevator and rudder. However, for this video, we're going to sort of be ignoring the elevator and rudders because we don't need to do the same for them for this particular video, just to show you how to add the servos. We'll just concentrate on the ailerons. Now, let's have a look at the current aileron setup. So this is 1 function with 2 channels. So basically the 1 function on the radio, which is the aileron function, controls 2 servos. So when I move my aileron stick, we're actually operating 2 servo channels. So what's going to happen basically is we're going to add some more servos to these 2 channels. And you think, oh, how in the hell are we going to do that? And well, the Mercury's going to do that for us, and I'll show you how. So instead of adding multiple servos in the radio, we're going to add them to the Mercury. So as far as the transmitter's concerned, it's still only going to be controlling 2 individual channels. So we're going to have like channel 1 or servo 1 and channel 2, servo 2. However, the Mercury is basically going to allow us to add a couple more servos to these channels. And we'll see how to do that a little bit later. So that's just one thing to be aware of. So when we add these servos are not really going to be controlled from the transmitter. They're really going to be controlled from the Mercury as far as, say, the center, the endpoints. The additional servos will be managed by the Mercury SR2 and not the transmitter. So another thing to be aware of is if we adjust the travel here, we're going to be adjusting the travel of all the servos attached to this channel, which you don't normally want to do unless you want to move all the servos equally. However, the get out of jail free card is another feature with the PowerBox units, which a lot of other manufacturers do not include, is a servo matching capability. So we're going to use a servo matching capability in the Mercury to match all the servo travels that are attached, say, to this particular channel. So if we have multiple servos on here, we have to match their travels somehow, and the Mercury and the competition and the Royal SR2 allows us to do that. Okay, let's move on to the next bit. I might just show you the actual Mercury itself and how we're going to rearrange some of the servo ports to suit our wiring layout out in aircraft. So this is a feature that I was asked about, so I decided to include it in this video. So the output mapping, we're going to change a few of the servos, and just to give you an example, I've written down the current configuration for the Mercury. So for instance, our elevator right is plugged into port B on the Mercury, rudder into port C. This is for the current servos. So elevator left is port O. So our aileron right and left servos are plugged into ports A and P. But I'm going to change these because it's not going to suit my current servo layout. Okay, let's have a closer look at the Mercury. Okay, bit of a close-up of the Mercury servo ports. So as you may be aware, these ports numbered using alpha characters. So we've got port A on the far right hand side, and the last port is port P, which is over here on the left hand side. And at the moment we've plugged in the servos for that particular example that I was just showing you as per the setup assistant. So at the moment we've got, for instance, the right aileron servo was plugged into port A, which is, I'll just get my little pointer again, which is that cable there, that plugs into port A. And then port B was one of the elevator servos, elevator right, I think, yep, elevator right. This is our rudder servo, port C. However, we're going to change these because, for instance, in this particular aircraft, I want all my aileron servos to be, we're going to be using 3 servos per aileron. So I want all my right aileron servos to plug into, say, port A, B and C. So we've already got one plugged into port A, so that's not a problem. So how do we change ports B and C? We're going to move the elevator right and the rudder servo off to one of the other 3 ports. And same goes for the end here. So at the moment, the last one, which is this cable here, plugs into port P. That's our left aileron servo, so we can leave that one programmed as it is. However, port O is the elevator left servo. So basically, I'm going to want the 3 left-hand aileron servos to use ports N, O and P. So they're the last 3 ports. So we're going to reconfigure those, and we're going to move the elevator servo here, which is currently on port O. We're going to move it to one of the other 3 ports, and I'll show you how to do that. We'll do that now actually and reconfigure the aircraft. I'll bring in my aileron wing, or my test aileron wing I should say, and we'll start setting up some servos. Okay, let's have a look at both of these screens now. So, adjusting or changing the output mapping. We can do that from the Mercury itself. So we can use the power switch as our input device, and we can scroll around to the output mapping screen. And in here we can select the various output port we want to change. So we've got, currently it's on P, and we can scroll through all the alpha ports, or the alpha character respective to the ports. So port A is the first port, port B, C, D, E, all the way through to P for Papa. That's one way of doing it. It's a little bit fiddly. Another way of doing it is from the core screen, which might be a better option for this video. So we just need to go into the Mercury's menu. Well, actually, I might come over from the left-hand side of the camera. Let's go into the menu, and then we can just basically select the output mapping screen. And if I do this correctly, we'll be able to see the changes on the OLED screen of the Mercury as well. Okay, so we're on output A on the core screen, and also output A on the little OLED screen of the Mercury. Getting a little bit of reflection there on the screen from my light. That's a bit better if I tilt the screen. Just got a little bit of blue tack holding the screen in place. Okay, you'll notice we've got output A, function type is gyro, however function type is labelled as FS. So if you watch one of my other videos, there is a bug in the firmware at the moment, so that'll be changed at a later firmware setting. So it's just really the characters are wrong. So when you see FS on the screen, just remember that pertains to the gyro function. And at the moment, output A is set to the right aileron. Now remember, we're not going to change the ailerons, so we still need the two aileron servos to start with, so we can leave them as they are. We just want to pinch the following ports, which will be ports B and C, because we're going to add two more servos for the aileron right, or the right aileron, for a total of 3, and we're going to do the same for the left servo. So if we want to pinch the next port, which is port B, and if I change to port B on the screen, oops, not C, I want port B. You notice it says gyro, elevator right, and that's just the failsafe function, which we're not interested in for this video. However, we want to change that. So basically, we want that to be another aileron right output, if you like. So we have to move the elevator function to another one of the 3 ports. So we're going to be using A, B, and C, and NOP for the 3 servos. So basically, 6 servos. So A, B, and C for the right-hand side elevator, and NOP output ports for the left-hand aileron. So we have to free up B and C. So basically B at the moment is elevator right, and you'll find C is the rudder. So you notice it says rudder. So how do we do that? Well, all you need to do is copy the function type and function settings to another free port. So for instance, let's pick a port, I don't know, somewhere in the middle of the device. So this will just really be where your wiring is nice and neat. So say port G, we'll put the elevator right function on port G. So we select port G. At the moment, port G's freed up, so it's only set up as a direct function. In other words, the PowerBox won't do anything. It'll just pass channel 7 through to port G. But we're going to change that. And if I scroll through to port G on the OLED screen, we should see that change as well. So we need to make this a gyro function. So remember about that bug. So we need to change that to FS. So we change it to FS, and the default that it puts in is the aileron function. However, remember we're moving the elevator right. So elevator right currently is on port B, but we're going to free that up. So we're moving it to port G. So all we need to do is basically scroll through the list here until you get to, oops, I just went past it. We want elevator right. And you'll notice the display's changed as well. So like I said, you can do it through here, through the core, or through the actual Mercury itself as well. So now we've actually moved it over to port G. So if you plug in a servo into port G, it'll mimic the elevator movement basically. Now let's go back to port B, because we haven't deleted or we haven't changed that. So it still has an elevator function on there as well. So I'll just change the OLED screen as well to port B. Actually, I could have just done that through the screen because it's the transmitter's following it. So port B, so now we've got port B and port G doing the same thing. So you can plug your servo, your elevator right servo, into either port B or port G and it'll work as the elevator right servo. However, we're going to free this up later and we're going to basically assign it to one of our other servos. And it's going to be, remember ports A, B and C we're going to use for the right aileron function. So all we need to do is change this to aileron right. So now we've got port A as aileron right. However, we also have port B as aileron right as well. Hope you're following this. Now port C was our rudder channel. So in our previous example, previous aircraft, port C is associated with the rudder function. So our rudder servo is plugged into port C. However, I want to free up port C because I want to use that as my aileron right to make the third servo. So remember, we're going to have 3 servos for the aileron right function, and we're using ports A, B, and C. So at the moment, we've programmed up port A as aileron right. Port B is also aileron right. And let's change port C, make that, oops, going the wrong way. We'll make that aileron right as well. So in other words, our right-hand aileron function. And if you scroll through on the display, I'll just select that with my switch. So you'll notice if you're looking at the OLED display over here on the right, the Mercury, port A, it's got gyro, aileron right. Port B is exactly the same setup. And now port C is also exactly the same setup. So theoretically, we can plug 3 aileron servos or right-hand aileron servos into those ports. So far, so good. Now, remember how we've deleted the rudder here? Let's pick a free port to set up our rudder function. So all you need to do is go to one of the other ports. Remember, we're using port G. Let's say pick, let's pick port H. We're going to plug our rudder servo into port H. So again, all we need to do is scroll around to the rudder gyro function type, which remember on the display shows up as FS. And if I change the OLED display to port H, we'll see the changes on here as well. So notice port H now is set to gyro. If I set it to direct, that's basically passing the servo channel straight through to the servos. However, we're going to change it to our rudder function. So all we need to do now is change the actual function to the rudder. And there we go. So now the gyro or the rudder function, gyro and everything will appear on port H. So we'll plug in our servo, our rudder servo into port H. Now, the only other one to free up was on the other side of, or the physical side of the Mercury, which is the last 3 ports. So if we scroll over to port P, which is already assigned as our aileron left function. So this is the left aileron servo. It's currently plugged into port P. So if I move the OLED display over to port P, that'll follow it through. So we've got gyro, so that can stay as it is, but we're going to use the adjacent servo port, so the one just before it. So let's have a look. That's port O. However, at the moment, that's assigned as our elevator left servo. But we don't want the elevator left servo for our new setup. we're going to be using the second aileron servo, the second aileron left servo. So all we need to do is basically set that to aileron left. Simple as that. However, don't forget, we've got to move the elevator left to a free port. So let's select another port, and let's go back a few ports. Which port shall we select? Wait for it to catch up. H was the rudder, so let's use the one adjacent to H. We'll make that the gyro function, which is FS, and let's change that to elevator left. So now elevator left is being used for the output I. So let's go back all the way. So now we've got two aileron servos, or two left-hand aileron servos. We've got one on port P, and we've also got port O. And remember, we're going to be using 3 servos for the ailerons, 3 on each side. So we want to change port N as well. So at the moment it's just set for straight through operation. That's what the direct means. So in other words, channel 14 on the radio doesn't get modified by the Mercury. If you plug a servo in there, whatever you do on channel 14 on the transmitter goes straight out to that servo. However, we're going to turn that into the gyro function. So again, if I change the OLED display, if I go around the right way, might help. We've got the FS, which means the gyro, and we're going to be using the aileron left, not elevator. Made a mistake. So now we have 3 left-hand aileron servos plugged into port N, port O, and port P. So our 3 left-hand aileron servos will be plugged into the last 3 servo ports on the Mercury, and our right-hand elevator servos, we've got 3 of those as well. They're going to be plugged into ports A, B, and C. And don't forget, we've moved the elevator servos, which I won't bother showing the actual servos as such, but they'll be plugged in. The elevator right servo will be plugged into port G. Rudder will be port H, and port I for the other elevator servo. Simple as that. So remember on this piece of paper how I had, this is our previous configuration. The 2 elevators were plugged into ports B and O, rudder into port C. They've now been shifted. However, our existing left and right, say number 1 servos if you like, our primary servos, they're still plugged into ports A and P, and we're just using the 2 adjacent positions on the Mercury, so ports A, B and C, and ports N, O and P, just to basically make the wiring nice and neat on the aircraft. So hopefully you follow that through okay. I got asked about it a few times by a few people, so hopefully that makes sense. Okay, we're now going to switch out my servo module. We're just going to go to the aileron wing, if you like, and I'll show you, we'll plug in the servos. I'll plug in the servos to ports A, B and C and NOP. I've got them labelled, so hopefully that'll be straightforward, and we're going to proceed to set them up. Okay, in front of us is my aileron wing. Well, sort of a wing. Now, this will be our right aileron, so hopefully you can read these labels. I've got this servo plugged into port A. I haven't plugged in ports P and C at this point in time, so these servos are not operational. So we've only got 1 servo plugged into port A, and over on the left hand side we've got port P being our left hand side aileron, and again ports O and N. However, I haven't plugged in these 2 servos at this point in time. So on the Mercury over here at the top of the screen, I've only basically got 2 servos plugged in. Like I said, I'm not going to worry about the rudder and elevator for this example, as we don't need to concern ourselves with that. So as far as the transmitter is concerned, I have not changed anything in the transmitter. So basically the transmitter's still the same. The only thing that we've done was change the output mapping, so to allow us to use ports O and N and B and C for aileron control. So when I move the aileron stick on my transmitter, I just get two servos moving. Now if you remember from my previous setup example, this is right aileron. However, I wanted to maintain the same consistency across my models. I want this servo to move up when I feed in right aileron input and it's going the wrong way. And the left hand servo, I want that to move down for right aileron stick input. So they're both going around the wrong way. So we'll have to change that in the transmitter. So something to be mindful of is when you set up a multiple servo aircraft, is you wouldn't connect these servos up initially. So you'd have the linkages disconnected. Otherwise, obviously, you'll be fighting against these two servos. So how we set it up is we select two servos to be our master servos or our reference servos. So I'm going to use port A and port P servos to be our reference servos. So what you do is you normally set these two servos up so they work 100% with your linkages. So you set your endpoints, your neutral, so they work perfectly with your linkages. You set the travel, and you can do that in the radio because we're using the two channels in the radio. So remember, we've got the single function, but the function's controlling two servo channels. So basically this is servo 2 or channel 2 on the radio, and this is channel 1 on the actual radio. And you can set the endpoints, the throws, all that sort of stuff in the radio for these two servos. And then later on when we add these guys, these extra servos, we're going to set the travel and neutrals, endpoints and all that, basically using the servo matching feature in the Mercury. So these servos, these four servos, these additional servos are going to be basically set up in the Mercury and controlled by the Mercury, not the transmitter. The transmitter will just control these two servos, and the Mercury will actually basically control these guys here. So you need to match these in the Mercury, and luckily PowerBox gives us a servo matching feature in the Mercury which allows us to do this. On some other systems you have to set these up in the radio, and you end up burning through a lot of channels if you've got a lot of multiple servos. With this particular method, we're still only using really two channels, two actual servo channels. So remember, one channel controls this side, the other channel controls that side. However, we can add servos to those, and because the Mercury is going to be managing these servos, we're not tying up extra channels in the actual transmitter as such. So as far as the transmitter is concerned, these four servos, these two additional servos on each side, do not exist. It doesn't know about them as such. Only the Mercury will know about them. Okay, I might just move over to the core screen now, and we'll reverse. Well, I probably don't need to show you on the core screen. Everybody knows how to reverse the servos. So, well, actually, I'll move over to the core screen. Give me a second to change to the screen. Okay, back to the screens, and you remember that we need to reverse the aileron servos. So this particular function I haven't changed from our previous setup. So if we go into the aileron servos, remember we're controlling the two, just two channels. At the moment they're set to reverse because we needed to operate them in that mode for the previous setup on my little test bed. But because these servos in this new test bed are mounted differently, I need to switch these back to normal. Okay, and now if I just check it, yep, basically the servos are now moving in the right direction. Now one thing too, I'll just remind everybody, whenever you fiddle around with directions or travel adjustments and stuff like that, we have to reteach the gyro, and we'll do that later when we have all the servos working, whatever. It's easy enough to do. We can just go into the gyro menu. We can teach the orientation of the gyro as well as reteach the sticks and all that. So we'll do that again right at the last sort of section to make sure the gyro works properly with the three servos on each aileron. Okay, now how do we add the additional servos? So at the moment, when I move the sticks, I'm just moving the servos on ports A and P. Well, what we need to do now is, if you were having a normal aircraft, you'd go ahead and set up your linkages. You would now add an additional servo one at a time, and you need to match its travel. So you'd use the servo matching feature inside the Mercury. And you can access that. The servo matching feature's quite good. You can actually access it from the radio. And we can have a quick look at that before we actually match up a servo. So if I scroll through, that's the gyro, input mapping, output mapping, and servo matching. So in here there's a whole lot of parameters. What I suggest you do though is, when you first buy one of these devices, is become familiar using the menu, the servo matching feature inside the PowerBox unit, because it's a little bit easier to understand if you haven't played around with this at this point in time. It's also got an automatic servo matching feature, which I'll show in a separate video. You can use that as well, but in this particular case we're just going to use manual matching. It's not hard to do manual matching, but I'll definitely show the auto matching in a later video. But just to keep this video a little bit short, we'll just use manual matching. So basically you set the output slot that you want to match. So that'll pertain to the slot or the socket that the servo is plugged into. So remember, we've got 3 servos on the right aileron, and they're plugged into ports A, B and C, and the port A servo is going to be our reference servo. So that's the one you set up first. You set up all your linkages, and you can set up the travels and whatever within the radio. And then once that's set, the other 2 servos are basically going to be set to match that servo. So port A servo is our reference servo. And the same goes for the left-hand side aileron. We've got a servo plugged into port P, and that's going to be our reference servo. So we don't need to match that to anything, because you do that within the radio. You match that to your linkages, and the other 2 servos that we add, the Mercury's going to match them to the reference servos, if you like. Okay, so to use the actual servo matching feature, you basically go into this menu. There's an option here to select which slot you're going to match. So basically, let's use slot B. So I'd select not C, but let me go back. Oops, hit the wrong button. Let's go back into the menu again. Let's select the output slot, port B, and what I might do now is, let's move back to the actual aircraft wing, and let's have a look at the servos. And what I'm going to do is, I'm going to shift one of the servo arms to pretend it's not matched. Okay, hang on a sec. Okay, so here's our little aileron wing testbed, if you like. And if I just lift this up slightly, we've got 3 labels here. So we've got on the right hand side wing, we've got ports A, B and C. So these represent ports A, B and C on the Mercury. And don't forget, port A is our reference servo. So this servo is being set up in the transmitter as far as travel, center, etc, etc. We're going to match these 2 guys up to this servo, and that's going to be done in the Mercury. And same goes for the left hand side of the aileron. So we've got ports P, O and N. Port P is our reference servo, so this servo again is matched in the transmitter as far as the linkages are concerned. And let me just get some of these wires out of the way. These 2 servos are going to be matched to that servo. So at the moment I've got these 2 servos operational, plus I've just plugged in this servo as well into the Mercury, which is just up here. So we've only got the 3 servos, left hand side aileron, right hand side aileron, the 2 reference servos, and we've just plugged in this servo here. And you know, if we were just real rough, that's sort of roughly matched at the moment. However, let's make the matching a bit more obvious. So let's shift this servo horn slightly. So now this servo is like way out of match. It's just not matched at all. And you can see there, travels all over the place compared to the other two servos, not tracking the same. How do we match it? Well, we're going to use the servo matching feature inside the Mercury to do that. So I might just zoom into the screen, and I might try and keep this in the picture as well. Okay, now we're looking at the OLED display of the Mercury, and we're back into the servo matching menu. Now remember that servo that we're going to match, which I offset the horn slightly, that's on port B. So you can see here on the display I've selected port B. So one of the next important steps is we have to tell the Mercury how far the stick travel is for that particular channel that we're going to use. So it's a bit like when you set the gyro, teach the gyro the stick travel, the maximum stick travel. Well, we do the same thing here on the Mercury as far as the servo matching is concerned. So what we're going to do is we're going to activate this initialize output, and then it's going to ask us to move the respective sticks. So in this case it's going to be the aileron stick, and we're just basically going to move it to one extreme and to the other extreme so it learns basically the maximum travel for that channel. Because remember, it's going to try and match output port B to the reference servo which is plugged into port A. Okay, so let's select that, and you'll notice there's a little display there, a little horizontal line with some arrows and some numbers there. Now I'm going to move my aileron stick to the far right, and you can probably hear the servos move, so I'm just moving it to the right. Then I'll move it to the left, and you'll notice little arrows right at the bottom of the display. They will move to the maximum throw that this channel gives it. So there you go. Done both sides. And once you've done that, that's all you need to do for the initialize output. So basically that's telling the Mercury the maximum travel for that particular channel. So when we get out of that, you'll notice there's an OK in the display now. So there was a dash before, I think, from memory. So now there's a little OK indicating that it's happy that you've taught it the travel endpoints, if you like, for that channel. So it now knows how far to move that servo as far as the maximum travel is concerned. Okay, now say we needed to reverse the servo. Now remember, we can't do it in the transmitter because remember how I was talking earlier at the beginning of the video that the transmitter's only got the 2 servo channels. So it's basically controlling our reference servos with those 2 servo channels. So if we reverse, say we want to reverse this particular servo, it'll reverse all the servos in that aileron function, or that for that channel. And we're basically using one channel to control 3 servos, so we can't use the reversing feature in the radio. However, there's a reversing feature in the PowerBox. So all you need to do is select it and highlight, little dot highlights there indicating that now the servo is reversed. However, for this particular example, I don't need my servo reversed since it's configured or mounted the same way as the other servo. So I can just leave that output as normal. You'll notice the last option is auto matching. We're not going to use auto matching in this particular case because I don't have linkages set up. So all you need to do is go into start matching. Now you get a little screen here with a little bar graph down the bottom. You notice there's a little inverted triangle that's flashing, and that's basically showing us our relative stick position. So if I move the aileron stick, you'll notice I can move it. And also notice there's 5 little triangles on the very bottom of the display. So basically those triangles are our set points that we can use to match the servo along its travel. So basically you have 5 points to set the servo matching. So you got one in the middle, so that's my center stick. So you got obviously the 2 endpoints. You've got one at full right hand stick, one at full left hand stick, and then you've got a point in the middle. So yeah, this is where we adjust those points. So remember that servo's offset. So what I need to do now is, I think if I press my button on my PowerBox switch, you'll now notice the bottom arrows flashing. So how we select the arrows is basically you move the, you make sure the top arrow is flashing. So you just got to do that via the switch on the power switch, the set switch. You move your stick to the corresponding arrow that you want to change, or the travel that you want to change. So if I hold it roughly there, I'm trying to hold it with my left finger, I'm wobbling a bit, but if I push the set switch, you'll now notice if I let go of the stick, I'm not actually holding the stick now. The radio or the Mercury is actually frozen the servos at that position, and now I can adjust it using the 1 and 2 buttons on the actual power switch. And like I said, you can actually do that in the radio in here, but I recommend you use the PowerBox first, get a handle on how it works, because once you've done that, then you can understand how it works in the radio menus. It's a bit more confusing going the other way. Okay. So what I want to do is I want to set the center point first for this servo, because it's far out on the center point. It's because I moved it one spline on the servo horn. So I've got it flashing at the moment. So I'm going to switch over to the servo now, or I might actually try and zoom out a bit and see if we can get the screen. I mean, if I hold it down now, you can see, if you look at the screen, you'll see the value change slowly. So I'm holding one of the buttons down. And you'll notice I've moved the cursor slightly. So the bottom arrow's moved along the trace now, and the servo's actually moved. You can't see it, but I'll show you that in a second. And this has actually got a very fine adjustment. So basically, you can actually click the switch a couple of times before the actual percentage value increments. I think it's about 5 times. So it's about 0.2% steps. The display doesn't show 0.2%, but you can actually adjust it in 0.2% steps. I'll just put it back to roughly, if I hold it down, it'll start speeding up. If I go back to say 0% output, there we go. I'll leave it there, and let's have a look at the servo, what it's doing. Okay, so here's our servo B, that's not matched. And remember the display on the Mercury, we had that flashing arrow. So all I'm going to do now is adjust that arrow again. And this time you'll see the servo move. So remember this one here, I've just moved the spline over one position. And if I just eyeball it from on top, camera won't pick this up 100%, but you get the picture. So I'm basically adjusting the center point now, and it's pretty much smack bang on center now. So at this point in time, we've adjusted the center point for this servo, so it matches the center of this servo. However, if we now, let me zoom out a little bit. If I move my aileron stick, actually I've just got to get out of the servo matching. I've just got to set that. Okay, so now if I move the servo aileron stick, I should say, not the servo stick, you'll notice the endpoints are still not matched. And that's because we've only adjusted the center. So you'll notice, especially in this direction, you can see the top servo's moving a lot different angle compared to the middle servo. So we still really need to adjust the other points. So let's go back to the OLED display, and I'll just refresh everybody's memory. How do we select the other points? Okay, now we're looking at the OLED display again. So you notice, if you look carefully at the bottom triangles, we've moved over this, the one that was sort of in the center before has now been moved over to the right slightly, or a fair bit actually. If I hit the set button again, it's actually flashing now. So that's actually our set point, or our set offset, which is about 25%. So this output value is corresponding to the flashing triangle. So how do we select the next point, or say the end point? So let's move the endpoint. How do we select it? So all we need to do is move the actual stick. But before we do that, I've got to hit the set button again. So you're going to make sure the top arrow's flashing. And now we move the aileron stick, and we move it over to the arrow or the position that we want to match. So basically, let's go to the far end position. So I now hold the stick there and push the set button. And now once that bottom arrow is flashing, I can let go of the stick, the aileron stick. I've actually let it go. However, the servos are now stuck in that far endpoint position. and that's to allow you to set up the travel without having to hold the stick over it. It's a good little feature actually. So once you've hit the set button, you now no longer have to keep holding the stick over, the aileron stick over to set the servo travel for that particular endpoint. Okay, let's have a look at the servo. Now we're at the, or looking at the servos I should say. So you can see this servo here is nowhere near this angle. So this is our reference servo, so we need to match this servo. So we're at the endpoint, so remember we selected the far right hand side endpoint. We need to match this servo to that servo. So this is our reference servo that was set by the radio, and this one's being set by the Mercury's servo matching function. Okay, let's adjust that last point. So if I hold down the button on my Mercury and providing I'm going the right way, it's slowly changing. If you hold it down, it starts to accelerate like that. So let's get it, I don't know, is that roughly right? Oh, maybe a bit too much. I'll just remember it can do 0.2% steps, so pretty fine adjustment. I mean, these aren't exactly high-grade servos either, but you get the picture. Okay, now what I'll do is I'll get out of that and we'll get the servo to move back to its neutral position or center point position. So remember we've matched, oops, sorry, I bumped the tripod. We've matched the center and the end point. I haven't bothered doing the midpoint. So you'll notice there's a bit of weird interaction here. So basically, as I move my aileron stick, you'll notice the top servo is still moving a lot quicker than the bottom servo, or further I should say. And then it's only until the last bit of travel where the bottom servo catches up. And that's because we haven't adjusted the point between the midpoint and the full throw point. So what I'll do is I won't bother going back to the OLED display, but I'm just going to move my aileron stick and then hit my center button. And now I can let go of my aileron stick. So this is the point that sets the midpoint between, sort of the halfway point between center travel and full travel. Now let's adjust the servo to match the reference servo. So again, just hold the switch down and it starts off slowly and then it starts to accelerate a bit faster. And I'm just trying to eyeball this with the camera in the way. I think that's probably about roughly right. The angles might not look 100% right with the camera. There's a bit of parallax error with the camera, I should say, not aliasing. But that looks about roughly right. Okay, hit the set button again. Let's have a look now. That's better. Look, 100% matched. Wow, pretty close. That's just eyeballing it, you know. That's pretty good. Now if I go the other way, we haven't matched the other way. So the other way is, you know, pretty average. However, if I go from center to top, it's perfect. And of course we can do the other way as well. So if I go full left stick, and if I get it to stay there, I can then reduce the throw a bit. Oops, going the wrong way. Go a little bit more, a little bit more. Oops, yeah, about there. Set that. And then I'll do the halfway point between center and full throw. Just going to reduce that a bit as well. See the toothpick moving slightly. Okay, that's pretty close. Okay, that's it. We've now matched the servo. So servo B is now matched to servo A. So remember we offset this arm one spline, but I've basically roughly matched it to match the travel with our reference servo on port A. So remember the transmitter doesn't really know about this servo. The Mercury did the matching and set all the travel on that for port B. Now, you can do the same for port C. We can do the same for the other two servos on the left-hand side of the aircraft, on the left-hand side aileron. And if you wanted to, we can also add another servo, so you can have 4 servos or 5 servos. The radio doesn't care because you're not using any more channels on the radio. You're just using ports on the actual PowerBox unit. Let's have a quick look back at the OLED display, and you can see how the travel has been offset to one side of the display. Okay, back looking at the OLED display, and if you look really carefully at the little triangles at the bottom of the display, you'll notice how they're all offset to the right, and that's because I offset the servo arm one spline. So we've had to move basically all the points over to basically get rid of that offset that I physically put in. And that's how you basically match the servos. Now, like I said, there's an auto servo matching feature as well. So when you have the servos attached, say, to multiple arm or basically the same linkages, the unit can actually measure the current that the servo's drawing and match that to the reference servo. And I'll cover that in another video because that's, again, probably a slightly longer video. Don't want to add to this video because it's long enough already. Okay, so that's how we match the servo. So now you go ahead and add the next servo, which was servo number C for our right aileron. And you'd go ahead and go through the matching process again, and you match it again to the reference servo. And of course you'd be doing that with your linkages and, you know, maybe using a little amp meter in series, amp meter in series with the servo to minimize current draw on that. It's pretty easy to do, obviously. And when you're using high performance and very accurate servos, it works really well. Okay, let me connect all the servos up, and I won't bother matching the other servos because they're roughly the same for this particular example. I haven't got any linkages attached, so if the travel's a little millimeter out here and there, it doesn't really matter for this example. But at least you get the picture of how to match a single servo, and you just have to go through the same process for all the other servos. Okay, let me connect the remaining servos up to the Mercury. Okay, you probably can't see the display too well, it's probably too small. However, I've reconnected all these servos now. So remember, on the right hand side aileron we've got this servo plugged into port A, B and C, and this servo is in port P, and we've got port O and port N. So now if I move my aileron stick, look at that, got 3 aileron servos per aileron. Of course, we could have a 4th and a 5th. It's just a matter of going into the output mapping screen and adding that gyro function to the particular port and telling it which function do you want. Do you want aileron or elevator or rudder? So you can see how easy it is to have multiple servos on the actual PowerBox unit. And like I said earlier in the video, is the number of gyro outputs has no real bearing on how many servos we actually have on each flight surface. Okay, one last step before we finalize this video, and that's the fact that because we've been playing around with the servo travels and that, we have to redo the gyro settings again. So I've got my little aircraft here. Remember this aircraft, my fancy glider. So we can actually reteach the gyro basically, and set the endpoints and all that again, and we'll just verify that the servos work in the right direction. So for instance, at the moment, if I move right aileron stick, the right hand side servos move up, and if I move left aileron stick, they move down, and of course the opposite happens on the left hand side of the aircraft, or left hand side of the wing I should say. So let's reteach the gyro. Obviously this is exactly the same as per the last video, so I'll just quickly run through that. I won't spend too much time with it. I might just move these up out of the way. We'll just step through the gyro settings and then we'll just confirm it all works. Okay, so we've got my expensive glider here with the gyro mounted on the unit. A bit floppy and whatever, but won't matter for this example. Let's have a look at the gyro screen on the core. So hopefully you can see this without too much drama. However, You can always refer to my previous video, so video number 3. Let's have a look inside the Mercury. Let's select or move over to the actual gyro setup screen. So this is where we teach the mounting position and the endpoints. You can either do one or the other. You don't really have to do both. However, for this video, I'll just do both just for the sake of clarity. And I'll try and keep the model fairly steady when I do this. So let's do the mounting position. So we just basically hit activate, and the radio will prompt us to move the tail up. And you won't hear any servos moving because I don't have a servo plugged into the tail output on the Mercury. So basically you're moving the tail up and down, and then I'll hold it up. So move tail up and hold it up, and you'll notice now the screen's telling us to move it to the right. So basically left and right action, and then hold it to the right. So just hold it to the right, and it's done. Once you've done that, that teaches the mounting position. We now do the endpoints, so I can probably move the aircraft out of the way. And let's do the endpoints. So similar thing, we hit the activate button. If I push it hard enough, it'll prompt us to move the aileron stick to the right. So full aileron right and hold it there. I then push the button, it teaches it, and then it will ask us to do aileron left. So one thing to be aware of is when you're teaching the stick endpoints, you've got to make sure you don't have any dual rates activated. You need the full maximum travel. So here we go, pull elevator up. So I'm pulling on my elevator stick, hit the up arrow, hit the right arrow, and then it's telling me to push the elevator stick down or forwards. And then it asks us to do the rudder. So again, it's imperative that you have full throw when you do this. So you just got to make sure you haven't got any rates, dual rates enabled. Okay, done. Now, once that's done, in theory the gyro should work. So let's move our little servo cluster here in view. Actually, I might just move the radio out of the way. Let's see what we got here. So remember, right stick, so right aileron. So we've only got aileron servos here. So as I move my aileron stick to the right hand servos move upwards. And obviously left aileron does the opposite. So let's put some gain in. And I do have heading hold or attitude assist, as PowerBox call it, enabled for the ailerons, which is the default. So I'm just going to dial in some gyro gain. So I've got about 30% there, and I'll just move the servos up a bit so you can see the aircraft a bit. I'll just set them back to center. So remember, the attitude assist is disabled when you move your stick. So the attitude assist is only enabled when your stick's sort of at center. So just something to be aware of. It's not like a normal heading hold on a normal gyro. Okay, so remember, right aileron, right servos move up, left servos go down. So let's roll the aircraft to the left. If I roll it to the left, it should correct by putting in a right aileron input, just like that. So let's see what happens. So let me lift the aircraft slightly. Let's roll it to the left. And there you go, the servos move in the correct direction. And obviously we don't have any tail or elevator servos plugged in, so I can't test that function at the moment. However, you can see all 6 servos, if you ignore the wobbling, because I'm wobbling the aircraft a bit, but you can see they're working fine. And that's how they should work. So now we've got 3 servos per aileron on this craft. And like I said, easy enough to add a 4th servo for each side, or a 5th, or even a 6th. It's not hard to do. You just basically add it, no different to how we matched this guy here. And at the moment, if you remember, that servo horn's still offset. So to get that out of the way, you know, that looks pretty matched as far as the eyeball's concerned at the moment. And that was just using, you know, a quick servo matching method that I showed you. Okay, hopefully you've learnt a fair bit in this video, and the main thing was to point out was, you know, the fact that don't look at how many gyro outputs you've got on a particular PowerBox device. It's really limited by the number of ports on the actual Mercury or the competition or the Royal, not the gyro outputs. There are certain cases where you need those extra gyro outputs. So for instance, I think I mentioned before about, on your rudder, you normally would assign one of the outputs for your rudder. If you've just got a simple rudder, you might have 3 servos on the rudder. You only need 1 gyro output on that rudder. However, you'd use like a second output for, say, a nose wheel if you had nose wheel steering, for instance, if you needed a gyro function on the nose wheel. It's probably more applicable to, jets and stuff like that, which tend to use gyros on their nose wheels. But then a lot of times the jets don't have 3 servos on their rudder, so there you go. Anyway, hopefully you've learnt a fair bit from this video, and stay tuned for some further videos. I still want to cover off the sequences, just basically show you that they're fairly easy, but I just want to show you how to use those. And we'll look at servo matching using the auto servo matching feature. I'll do that in a later video as well, but I'll probably have to set up some sort of linkage just to give you an example of how well it works. Okay, thanks all for watching.